In this lesson, we're going to take a look at how to show patterns and relations in tables. To do this, we are going to treat our relations that we've been talking about, our algebraic expressions, and try to take these patterns and relations and plug them into a machine to get inputs and outputs. Now, you might be confused what I mean by that, but really it's simple. When you have a machine, you put material into the machine is programmed to do something, and then based on what the machine is programmed to do, it's going to make something or spit something new out. Here's an example of a table in the form of a machine. In fact, you've already seen something like this before in the previous lesson. This time it's going to be worded just a tiny bit differently, but it still works exactly the same way as what you've already seen. The left-hand side of the table is going to be called your input. This is what we're going to be plugging into the machine, the numbers below the input. The output is what we're going to be getting once we have plugged the numbers into the machine. So we're going to put something in, we're going to get something out. Each machine has its own program, and the program is going to tell us what numbers we are going to be able to get out of the machine. Let's pretend that this particular machine has a program called 2n plus 3. So, the input is going to stand for our variable, our letter. So we're going to plug these numbers in to the spot for n, and then the program is going to help us determine what we're going to plug out. So take a look. 2n plus 3. Let's replace the n first with the number 1. So I'm going to take 2n plus 3 and I'm going to replace it with the number 1, which is my first input number. So there, I've replaced it with the number 1, and now I'm going to find out what answer I got. So remember, when they're close together, it means you're multiplying. So 2 times 1 is 2, plus 3 is 5. So what did you get? If we plug in the input of 1 into this program, 2n plus 3, we get an output or an answer of 5. Okay, let's try to plug in the input of 2 using the same program. 2n plus 3. 2 times 2 plus 3. 2 times 2 is 4 plus 3 gives us 7. So I get now, and with an input of 2, I should say, I get an output of 7. And it's going to work every single time. Let's plug in 3. 2 times 3 is 6, plus 3 is 9. 4 times 3 is 12, plus, 4 times 2 is 8, plus 3 is 11. And then, of course, the last one gives us 13. So if I plugged in all of these input numbers into this program up here, this algebraic expression, 2n plus 3, I'm going to get the output of 5, 7, 9, 11, and 13. And this is an example of showing how we can do these patterns and relations in tables, showing them as a table. Let's show another example. In this input-output table, I have a relation, a program of 10 take away m. Remember that the variable, the letter m, is always represented by the input. So whatever letter you have, it's always the input. So let's plug in the input numbers for m and see what we get for output. Our first input number, again, is the number 1. So let's replace m with 1 and see what we get. 10 take away 1 is 9. Okay, let's go to the next one. 10 take away 2 is 8. Go to the next one. 10 take away 3 is 7. And we keep going all the way down. Here's another example of an input-output table showing the relation 10 take away m. Now sometimes we have to do the reverse, where we have the input and the output, and we have to figure out what program we are using to get this information. This is called finding the relation from the table. In other words, What did I do to the left-hand side, this side over here, to get to the right-hand side over here? What did I do from 1 to get to 7, and from 2 to get to 14, and so on and so forth? It has to work the same way every time. Remember that the input is always going to be our variable. So we're going to call the input n. What did I do to n, these numbers down here, to get to the other side? Well, we could go n, in other words, 1 plus 6 gets me to 7. Okay, that works. But remember that it has to work every time. Let's try it with the next one. 2 plus 6 gives me 8. Did that work to 14? No. 3 plus 6 give me 9. Does that get me to 21? No. So plus 6 is not going to work for this program, for this relation. Let's try another solution. How about multiply by 7? 1 times 7 gets me to 7. Okay, good. Let's try the next one. 2 times 7 is 14. Good. 3 times 7 is 21. Now we're getting there. 4 times 7? 28. Okay, so multiplying by 7 works. How are we going to show multiplication by 7 in a relation using an algebraic expression? Remember that we do not go n times 7 because that's the incorrect way of showing it. In algebra, we always have to show it squished together. Multiplying is squished together. So n times 7 would be like saying 7n. In other words, 7 times n. So your correct answer for this table, the program for this table, is 7n. This is an example of how to use patterns and relationships in tables and also how to figure out the relation from tables.